What if I told you the most powerful car in the world doesn't roar? No thunderous engine, no vibrating exhaust, no mechanical growl echoing through the streets. Just silence. And in that silence, power. Today, we're diving into something that sounds almost impossible, a machine so quiet it feels unreal. A vehicle that doesn't just reduce noise that erases it. This is the story of the soundless machine, Maxwell Chikumbutso's quietest creation. Across the globe, electric vehicles have already begun replacing combustion engines. Companies like Tesla proved that speed doesn't require gasoline. Legacy giants like Mercedes-Benz and Toyota are racing to electrify their fleets. But Maxwell Chikumbutso isn't trying to compete in the same lane. He's trying to redefine the road entirely. Born in Zimbabwe, Maxwell Chikumbutso has built a reputation around bold technological claims and futuristic prototypes. While the global automotive industry focuses on battery capacity, charging infrastructure, and range anxiety, Maxwell's vision centers on something far more radical: self-sustaining systems and ultra-efficient propulsion technologies. And now he introduces something different. Not the fastest, not the flashiest, but possibly the quietest. Imagine standing beside a running vehicle and hearing absolutely nothing. No idle hum, no cooling fan, no electrical whine, just air. Traditional electric vehicles still produce sound. The inverter sings at high frequency. Cooling systems circulate fluids. Tires grip asphalt with friction. Even in silence, there is mechanical presence. But this machine aims to go further. Maxwell's approach reportedly integrates advanced electromagnetic propulsion concepts designed to minimize mechanical resistance. The fewer moving parts, the fewer vibrations. The fewer vibrations, the less sound energy escapes. Silence is not accidental. It is engineered. Think about that for a moment. For over a century, sound has defined power. Since the era of Ford Motor Company and the birth of mass production, engine noise became emotional branding. Muscle cars roared to signal dominance. Supercars screamed to announce speed. Even electric vehicles introduced artificial sounds to replace what was lost. Because humans equate noise with strength, Maxwell challenges that psychology. He suggests that the future of performance isn't louder. It's quieter. But why does silence matter? Because noise is wasted energy. In physics, sound is vibration. Vibration is energy escaping the system. If a machine produces less sound, theoretically, more energy remains directed toward motion. Less dissipation. Greater efficiency. The soundless machine isn't about muting the world. It's about maximizing internal precision. Picture driving through a city at night. Streetlights reflect off polished bodywork. The vehicle glides forward without announcing its presence. No engine echo bouncing off buildings. No exhaust disturbance. Just motion, smooth, uninterrupted motion. In that moment, driving becomes something else. It becomes immersive. Without noise, your senses recalibrate. You feel the acceleration more intensely because there is no auditory distraction. You sense the road texture through subtle feedback. You become hyper-aware of movement. Silence amplifies sensation. That's the paradox. And then there's the engineering question. How do you cool a system without fans? How do you manage torque without gearbox chatter? How do you eliminate harmonic resonance inside a metal chassis? This is where advanced materials science comes in. Composite structures dampen vibration differently than traditional steel frames. Magnetic propulsion systems reduce contact friction. Precision-balanced rotating elements cancel oscillations before they propagate. Even mainstream innovators like Rimac Automobili focus heavily on vibration management in Hyper-E-Versus. But Maxwell's concept pushes beyond performance into acoustic invisibility. There's also a strategic dimension. Cities worldwide are grappling with noise pollution. Urban planners measure decibel levels like health statistics. Chronic exposure to traffic noise correlates with stress, sleep disruption, and cognitive strain. A fleet of truly silent vehicles wouldn't just change transportation. It would change cities. Imagine highways without the constant low-frequency rumble. residential streets where traffic passes unnoticed, emergency vehicles engineered to project directional alerts without broad acoustic pollution. Silence becomes infrastructure. And yet, controversy follows innovation. Skeptics question feasibility. Engineers debate the physics. Critics demand independent verification. That tension is part of the narrative surrounding Maxwell Chikumbutso. Visionary to some, controversial to others. But every disruptive idea begins as improbable. There was a time when wireless communication sounded absurd. A time when electric cars were dismissed as impractical. A time when landing reusable rockets seemed impossible until companies like SpaceX proved otherwise. The soundless machine sits in that same category of bold ambition. And here's the deeper layer most people miss. Silence isn't just mechanical. It's philosophical. In a world dominated by constant digital noise, notifications, engines, media, traffic, a silent machine becomes symbolic. It represents control, precision, restraint. It suggests that true power doesn't need to announce itself. It simply operates. Now imagine this technology evolving. Scaled for public transit, integrated into freight systems, applied to autonomous fleets. What happens when logistics networks operate without acoustic disturbance? When delivery trucks move through cities at dawn without waking entire neighborhoods? The ripple effects expand beyond automotive headlines. Energy efficiency improves. Urban stress declines. Design language shifts toward minimalism. And then there's the competitive response. If Maxwell's silent propulsion proves viable, major manufacturers will take notice. Companies like BYD Auto and Volkswagen Group invest billions into next-generation EV platforms. A breakthrough in acoustic elimination would redefine engineering priorities overnight. Because once consumers experience true silence, there's no going back. But here's where the story becomes even more intriguing. What if the silence isn't just about removing sound, but about eliminating dependence? Some of Maxwell's past concepts revolve around energy autonomy, self-sustaining systems, reduced reliance on conventional charging infrastructure. If a vehicle operates quietly and independently, it challenges not just automakers, but energy grids. And that's where the conversation shifts from engineering to disruption. Because the most dangerous innovations aren't the loudest ones. They're the quiet ones. Continue watching closely, because what happens next could determine whether this machine becomes a historical footnote or the beginning of a silent revolution that reshapes mobility as we know it. And as this prototype moves from concept to demonstration, new questions emerge about validation, scalability, global partnerships, and the reaction from established industry leaders who have built empires on combustion, branding, and controlled technological evolution. Behind closed doors, analysts would begin calculating the implications. Venture capital firms would monitor feasibility reports. Engineers would dissect component schematics. Governments would quietly assess regulatory frameworks. Because if silence becomes the new benchmark of performance, the entire hierarchy of automotive excellence changes. Speed alone no longer dominates headlines. Decibels do. Or rather, the absence of them. And somewhere in Zimbabwe, inside workshops far from Silicon Valley and European automotive capitals, a narrative continues to unfold, one that could either dissolve under scrutiny. And as global attention begins to intensify, something fascinating starts to happen. The conversation shifts from, is it real, to what if it is? Because throughout technological history, skepticism has always been the first gatekeeper of transformation. When early electric pioneers challenged combustion dominance, they were dismissed. When renewable energy threatened fossil fuel dependency, it was labeled unrealistic. Yet here we are. Now imagine engineers from established automotive laboratories quietly studying vibration dampening techniques. Imagine acoustic physicists analyzing resonance suppression models. Imagine research teams attempting to reverse engineer a propulsion architecture that leaves behind almost no audible footprint. Silence becomes the new arms race. Traditional vehicles are designed around managing explosions. Even electric cars are built around battery weight distribution, thermal control, and motor harmonics. But if the soundless machine truly minimizes moving parts and mechanical friction, it represents a philosophical shift in engineering priorities. Fewer rotating components, lower harmonic oscillation, reduced energy bleed. When energy stops escaping through sound and heat, efficiency curves begin to change. And efficiency is everything. Because the automotive future isn't just about speed, it's about sustainability. Every watt conserved matters. Every percentage point of improved conversion efficiency influences range, durability, and cost-effectiveness. But here's the subtle detail most viewers overlook. Noise is not only mechanical, it's structural. Car bodies amplify vibration. Metal panels resonate. Air cavities inside doors and frames create acoustic chambers. Even tires generate patterned frequencies as they interact with asphalt textures. To create a truly soundless machine, you must address the entire ecosystem of motion. That means advanced composites that absorb micro-vibrations before they propagate. It means precision engineering tolerances so tight that internal friction barely registers. It means recalibrating suspension systems to dampen road noise at the source rather than insulating it afterward. This isn't soundproofing. This is sound prevention. Imagine the implications in performance testing facilities. Decibel meters registering near ambient readings while the vehicle accelerates. Engineers standing beside a moving machine, straining to detect mechanical output that simply isn't there. Psychologically, that changes the driving experience. Without engine feedback, drivers rely more on tactile cues, steering resistance, seat pressure, gravitational shift during acceleration. The sensory hierarchy reorganizes itself. Driving becomes intuitive rather than auditory. And then there's safety. Regulators have long debated minimum sound requirements for electric vehicles to protect pedestrians. A car that approaches in total silence raises important questions about urban coexistence. Would adaptive directional audio systems be introduced? Could ultrasonic proximity signals replace traditional engine noise? Would cities redesign pedestrian awareness systems entirely? Silence forces innovation in adjacent industries. Insurance models would adapt. Infrastructure design would evolve. Even marketing language would transform. For decades, automakers sold emotion through sound, the growl of torque, the scream of RPMs climbing toward redline. Now imagine advertising campaigns built around tranquility. Feel the motion. Hear nothing. That statement alone disrupts a century of automotive identity. But beyond marketing, there is geopolitical context. If a breakthrough of this magnitude originates outside traditional Western or East Asian automotive hubs, it reshapes global innovation narratives. Countries not typically associated with automotive dominance begin entering conversations once reserved for Germany, Japan, China, and the United States. Innovation decentralizes. And when innovation decentralizes, investment follows. Universities begin studying new propulsion theories. Independent laboratories attempt replication. Patent filings increase. Conferences host panels discussing acoustic minimization in vehicular systems. A silent vehicle sparks very loud discussions. Meanwhile, competitors would face an existential question. Do we refine combustion further? Do we improve battery density? Or do we pivot towards silence as the ultimate benchmark of refinement? Because once consumers experience the absence of mechanical chaos, the roar of a traditional engine may begin to feel archaic, almost primitive. And yet, this transformation won't happen overnight. Prototypes must survive endurance testing. Materials must withstand temperature fluctuations. Long-term durability studies must confirm that reduced mechanical complexity doesn't introduce unforeseen weaknesses. True disruption survives scrutiny. The world would demand independent validation. Third-party testing labs. Transparent demonstrations. Performance metrics under controlled conditions. If those validations succeed, momentum becomes unstoppable. And think about long-distance travel. Imagine cruising at highway speeds where wind resistance becomes the dominant sound, where cabin noise is reduced to the faint whisper of air displacement. Conversations become effortless. Music sounds richer because there's no engine hum competing in the background. Silence elevates luxury. Now consider military or specialized applications. Vehicles operating in environments where acoustic detection is a vulnerability. Silent propulsion systems would shift tactical dynamics entirely. Again, the ripple spreads. But perhaps the most profound transformation is cultural. For over a century, children grew up associating cars with sound. Toy engines imitated revving noises. Movies dramatized chases with roaring crescendos. Motorsport built entire fan bases around the visceral scream of combustion. A silent generation of vehicles rewrites that cultural imprint. Future children may grow up thinking loud engines are relics of a less refined era. And in that transition, the soundless machine becomes more than transportation. It becomes symbolism. A symbol of controlled power. A symbol of efficiency over spectacle. A symbol of innovation emerging from unexpected places. Yet tension remains. Will established automakers collaborate or compete? Will governments support or regulate cautiously? Will investors embrace or hesitate? Every breakthrough stands at a crossroads between validation and dismissal. And somewhere inside research facilities, engineers may already be attempting to replicate ultra-low acoustic propulsion, quietly acknowledging that if this concept proves viable, the definition of automotive excellence changes forever. Because in the end, the loudest revolutions in history often begin in silence. And if this machine continues evolving, refining, testing, proving, the next decade of mobility might not be defined by horsepower figures or battery range comparisons. It might be defined by a single, almost poetic metric. How little can you hear while feeling everything? And as whispers circulate through the industry, as prototypes roll across testing grounds without announcing their presence, the world waits, not for a roar, but for proof, because sometimes the most disruptive presence is the one that doesn't demand attention. Picture the first large-scale demonstration. No dramatic engine revving for the cameras. No smoke. No theatrical countdown. Just a vehicle positioned on an open stretch of road. Engineers standing nearby. Measuring equipment calibrated. High-sensitivity microphones placed at strategic intervals. The machine activates. And nothing happens. At least, nothing audible. Yet the vehicle begins to move. Acceleration without announcement. Motion without mechanical declaration. Data screens begin to register torque output, energy transfer rates, velocity climb, all while decibel readings hover barely above environmental background levels. That moment would redefine perception. Because the human brain expects correlation. Power should sound like something. Speed should generate acoustic confirmation. When that confirmation disappears, the experience feels almost supernatural. And that psychological shift is powerful. Luxury brands have long understood that refinement is about reducing unwanted noise. Double-glazed glass, acoustic insulation, active noise cancellation. But those solutions suppress sound after it's created. The soundless machine proposes something more radical. Eliminate the cause. If propulsion relies on systems that dramatically reduce mechanical friction, if rotational mass is minimized, if magnetic interactions replace traditional contact-based force transfer, then vibration declines at its source. And vibration is the birthplace of sound. Now, imagine scaling this philosophy beyond a single prototype. Public transport fleets that glide through metropolitan corridors without adding to urban stress. Ride-sharing vehicles that move through residential zones at night without disturbing sleep. Freight corridors operating near population centers without constant low-frequency rumble. City planners would notice measurable differences in ambient sound levels. Health researchers might correlate reduced noise pollution with improved cardiovascular metrics and cognitive performance. Silence becomes public health infrastructure. But the transformation wouldn't stop at cities. Consider rural environments. Agricultural zones where machinery noise has long been accepted as unavoidable. Silent heavy-duty platforms could operate with dramatically reduced acoustic disruption to wildlife ecosystems. Environmental impact expands beyond emissions. It reaches into acoustic ecology. And then there's autonomy. Self-driving systems depend heavily on sensors, lidar, radar, ultrasonic detection. A propulsion platform that produces minimal internal interference could enhance sensor clarity. Less vibration means more stable sensor arrays. More stable sensor arrays mean higher precision data capture. Silence supports intelligence. Suddenly, the vehicle is not just quiet, it becomes a better computational platform. Now step back and consider economics. If reduced mechanical complexity lowers maintenance requirements, ownership costs decline. Fewer moving parts mean fewer failure points. Lower friction means less wear. That shifts lifecycle cost models significantly. Fleet operators would pay attention. Insurance companies would reassess risk models. Logistics giants would calculate long-term savings across thousands of units. And if those calculations prove favorable, adoption accelerates. But every revolution faces resistance. Combustion heritage runs deep. Entire industries revolve around engine manufacturing, exhaust systems, transmission engineering. A propulsion paradigm that minimizes these components challenges established supply chains. Transformation is rarely welcomed by incumbents, which means collaboration becomes strategic. Forward-thinking manufacturers might seek licensing agreements. Joint ventures could form. Research partnerships with universities could explore materials science breakthroughs needed to optimize acoustic minimization. Behind the scenes, conversations would grow louder, even if the vehicles themselves remain silent. And culturally, the symbolism deepens. We live in an age of constant stimulation. Digital alerts, streaming content, algorithmic feeds, noise is everywhere. A machine that operates in disciplined silence becomes almost meditative. Driving transforms into an experience of focus. No engine crescendo competing with thought. No mechanical distraction. Just movement and awareness. Performance redefined as presence. But here's where the narrative tightens. If this technology matures, regulatory frameworks must evolve. Safety protocols would require innovation. Perhaps vehicles would emit intelligent, directional alerts only when pedestrians are detected. Perhaps urban crosswalks integrate smart systems that communicate with silent vehicles in real time. Infrastructure becomes interactive. And as more silent machines enter circulation, cultural memory shifts. The roar of combustion becomes nostalgic rather than aspirational. Car meets that once celebrated exhaust notes begin showcasing refinement metrics instead. How quiet is it? Replaces how loud is it? That shift alone signals generational change. Yet the path forward remains uncertain. Prototype testing must expand into extreme climates. High humidity, desert heat, mountain altitude, long-distance endurance under continuous load. Only sustained performance validates credibility. Engineers will push limits deliberately, stress testing components to uncover hidden vulnerabilities. If the system maintains acoustic stability under strain, confidence grows. And with confidence comes capital. Investment fuels research. Research accelerates iteration. Iteration refines design. Gradually, what once seemed improbable starts looking inevitable. But perhaps the most intriguing outcome lies not in dominance, but in influence. Even if the soundless machine never becomes the most widely produced vehicle, its philosophy could permeate the industry. Competing manufacturers would prioritize acoustic engineering more aggressively. Suppliers would innovate new vibration-absorbing materials. Designers would rethink structural resonance from the ground up. A single quiet idea could echo through an entire global industry. And somewhere in the background, while debates continue, while skeptics analyze and supporters advocate, the machine keeps moving. No dramatic soundtrack. No mechanical applause. Just forward motion. Because the future of mobility may not announce itself with thunder. It may arrive softly. It may transform cities gradually. It may redefine luxury subtly. And one day, when people look back at the era of roaring engines and constant urban rumble, they might realize that the turning point wasn't marked by a loud breakthrough headline. It was marked by an absence. an absence of noise, an absence of vibration, an absence of mechanical chaos. And in that absence, the new standard was born. But the journey is still unfolding. Research continues. Demonstrations expand. Questions multiply. Will silence become the ultimate symbol of power? Will the automotive hierarchy reorder itself around acoustic refinement? Will future highways hum with nothing more than the sound of wind? The answers aren't shouted. They're emerging quietly. And as this evolution progresses, one thing becomes clear. And feeling, in this new era, becomes the ultimate measure of truth. Because when sound disappears, sensation sharpens. Acceleration feels more immediate. Cornering feels more precise. Even stillness feels intentional. Imagine sitting inside the cabin at full stop. No idle tremor beneath your feet. No subtle steering wheel vibration. Just a suspended moment, as if the machine is waiting, perfectly balanced between motion and rest. Then you press the accelerator. Instead of a surge announced by sound, there is a seamless transition. The horizon begins to move toward you. Buildings slide backward. The world shifts, but the cabin remains eerily calm. That contrast creates a new kind of drama. External chaos, internal serenity. And that duality could become the defining signature of next-generation mobility. Now consider high-speed travel. At 100 kilometers per hour, 150 even higher. In traditional vehicles, speed multiplies noise. Wind turbulence mixes with engine frequency. Tire roar intensifies. Mechanical strain becomes audible. But in a truly sound-minimized platform, wind becomes the dominant voice. And wind is pure physics. No combustion. No mechanical symphony. Just air interacting with form. That forces designers to rethink aerodynamics entirely. Because once internal noise is nearly eliminated, even minor airflow disruptions become noticeable. Engineers would refine body contours to reduce microturbulence. Side mirrors might disappear in favor of camera systems. Door seals would become more advanced. Underbody panels would be sculpted for laminar flow precision. Silence raises standards. It exposes imperfections. And exposure drives excellence. Now imagine nighttime highways years from now. Streams of vehicles moving at coordinated speeds. No rumbling chorus of engines. No distant highway hum bleeding into neighborhoods miles away. Instead, a soft, almost imperceptible movement of air. Infrastructure planners might redesign residential zoning around this new acoustic reality. Property values near transit corridors could shift. Architectural design might change, no longer prioritizing heavy sound insulation against traffic noise. Entire industries adapt to the absence of something once considered permanent. And then there's energy psychology. When drivers don't hear power, they start observing efficiency metrics more closely. Dashboards may highlight real-time energy flow visualizations instead of RPM gauges. Software interfaces become central to the driving narrative. Digital feedback replaces mechanical feedback. The relationship between human and machine becomes more informational than auditory. And in that transition, mobility evolves from raw mechanical expression to intelligent energy choreography. But revolutions are rarely linear. There will be pushback from purists, enthusiasts who cherish the roar of performance engines. Motorsport communities built around the visceral scream of acceleration. Cultural identities tied to exhaust notes and mechanical aggression. And that resistance matters. Because every technological leap must reconcile with emotional heritage. Perhaps silent performance divisions emerge alongside traditional platforms during a transitional era. Perhaps synthetic soundscapes become customizable for those who crave auditory drama without mechanical noise. Ironically, silence might make artificial sound more artistic. Composers could design immersive audio signatures that respond dynamically to acceleration patterns. Instead of replicating combustion, they might create entirely new acoustic languages, futuristic, ambient, expressive. Sound becomes optional rather than inevitable. That choice alone represents freedom. Now zoom out further. If silence spreads across personal vehicles, freight systems, buses, even aviation concepts, global soundscapes begin to change. Satellite imagery might not show the difference, but environmental audio recordings would. Cities once defined by traffic noise would gain new acoustic identities. Birdsong becomes more audible. Conversations travel farther. Public spaces feel calmer. This is not just an automotive shift. It's a sensory shift. And as this transformation unfolds, global competition intensifies quietly. Research divisions across continents invest in ultra-low acoustic propulsion studies. Patent filings referencing vibration cancellation, magnetic stabilization, and resonance suppression increase steadily. Governments begin funding innovation grants targeting acoustic minimization as part of sustainability programs. Universities establish specialized labs focused on silent mobility engineering. What began as a bold prototype becomes a catalyst. But the real tipping point arrives when data becomes undeniable. Independent test facilities confirm ultra-low decibel readings under load. Long-term durability reports show stable performance. Energy efficiency metrics surpass expectations. At that moment, skepticism loses ground, and adoption begins accelerating faster than sound ever could. Automotive expos would showcase silent demonstration zones, spaces where visitors witness vehicles moving without the usual sensory cues. Journalists struggle to describe the experience because language has long tied speed to sound. How do you explain power you can't hear? They might ask. You explain it through numbers, through measurable performance, through felt acceleration, and gradually language adapts. Quiet no longer implies weakness. Quiet implies mastery. Mastery over friction. Mastery over vibration. Mastery over wasted energy. That reframing reshapes branding across the industry. Performance becomes synonymous with refinement rather than aggression. Luxury aligns with tranquility rather than isolation. Innovation aligns with subtraction rather than addition. Remove noise. Remove inefficiency. Remove excess. What remains is precision. And as research continues, second-generation models,